Look around the room you're sitting in. Right now, there are dozens of invisible, highly encrypted conversations passing straight through the physical space around you. We're talking streaming video packets, banking data, and authentication handshakes, all slicing through the air. We take the convenience of instant internet for granted, but keeping those massive, chaotic data streams perfectly separated requires rigorous architectural orchestration, starting right at the physical hardware level. This diagram illustrates a standard network build. Focus on phase 1 on the left. Every wireless network starts with a physical wire entering the house. Usually, an internet service provider delivers both broadband data and high-frequency television signals down a single coaxial cable. Because they share the exact same physical copper wire, we install a splitter to divide the traffic. One line feeds the TV, and the other feeds a dedicated cable modem, which translates those incoming analog radio frequencies into digital frames your local router can actually read. That translation point introduces the primary challenge of modern networking: designing an environment that provides seamless access for legitimate users, while strictly isolating and rejecting any traffic that lacks proper authorization. To achieve that seamless experience, hardware manufacturers make a calculated operational trade-off. They want to avoid millions of customer support calls from people struggling with a complex initial setup, so they prioritize a frictionless plug-and-play deployment. As a result, newly installed routers routinely ship with universally known default credentials for their graphical user interface, or GUI. We are talking about combinations like admin for both the username and the password. Retaining these default credentials allows any attacker to gain administrative access, granting them the power to reroute traffic or disable security protocols across the entire local environment. Look at the hardening and IP management section on the tablet screen here in Phase 2. The very first non-negotiable defense mechanism in deploying a network is locking that administrative front door by immediately replacing the default password with a strict custom string. This administrative portal is known as the management plane. If you do not secure this specific access point first, any further attempts to defend your network are essentially meaningless. Once the hardware is locked down, people naturally worry about their wireless signal bleeding into the neighborhood. This leads to a pervasive consumer habit: disabling the network's name, the SSID broadcast, assuming that hiding the name makes the network invisible to attackers. At the protocol level, this tactic fails structurally. An access point constantly emits what are called beacon frames to announce its presence. If you disable the name broadcast, the router still transmits its hardware footprint. It just leaves a blank slot where the network name should be. The flaw gets worse. Whenever your legitimate devices, like your laptop or phone, try to reconnect to that hidden network, they actively transmit the missing network name in clear text via a probe request. They are essentially announcing the name into the air, exposing it to any nearby listener with basic packet sniffing tools. Security through obscurity is a trap.
It inconveniences you and your guests while offering zero actual protection against an attacker who understands the underlying wireless protocols. The engineering solution for securing your data plane is to intentionally broadcast the network name in the open, but lock the frequencies down. Looking back at the center of the diagram under Phase 2, we accomplish this by setting the security type to WPA2 personal. To make this work, we assign a strict, case-sensitive passphrase. Capitalization matters heavily here, because a Wi-Fi passphrase isn't a standard password being checked against a static database. That specific string of characters serves as the mathematical seed material for the Advanced Encryption Standard, or AES. The router uses the exact sequence of letters and symbols you typed to perform the cryptographic math that scrambles intercepted radio waves into unreadable garbage data. Because WPA2 acts as an encrypted barrier, leaving your network name highly visible to your neighbors is completely safe. We have one final defensive pillar to configure on the control plane. Whenever a device joins the Wi-Fi, the router's DHCP server automatically assigns it a local IP address using a 4-step negotiation process: discover, offer, request, and acknowledge. Think of it like a host at a busy restaurant automatically handing out table numbers to guests as they arrive. We can leverage this system as a proactive security mechanism by intentionally starving potential attackers. Instead of leaving a pool of hundreds of available IP addresses open for the taking, we go into the settings and strictly cap the maximum number of users at exactly 10. If an attacker actually manages to bypass your Wi-Fi encryption and connects to the radio wave, they immediately broadcast a request for an IP address. But because the router physically has 0 addresses left to hand out, it simply drops the request. This simple settings tweak utilizes resource exhaustion to create a localized, intentional denial of service. It traps the attacker at the edge of the network, preventing them from communicating with your internal devices or reaching the broader internet. A theoretical configuration means nothing until the packets actually flow. You always have to validate the entire setup from the client side. Check the Phase 3 section of our schematic. The ultimate validation test is opening a web browser on a wirelessly connected laptop and successfully loading a specific external target server to prove the internet circuit is complete. When that page loads, it proves that the WPA2 handshake, the DHCP address assignment, and the router's internal gateway logic have successfully converged to complete a functional circuit. Separation of privileges, a custom login for the physical architecture, encrypted mathematical parameters for the radio waves, and a strict cap on the available address pool. Consider the vulnerabilities existing in your own living room right at this very second. When was the last time you checked your router's GUI password? Are you still using admin? Have you limited your DHCP pool to protect yourself from your neighbors? It is time to abandon the trap of invisible networks. Take these exact networking protocols and actively engineer a secure grid in your own home today.
Good morning, good afternoon, good evening. This is Professor Sistrunk, and I'm reaching out to the student body. Okay, students, like I often like to say, not another one. We got another packet tracer here. As you can see, this packet tracer is 4.4.4 packet tracer. Now, this particular packet tracer is pretty much something I do all the time, but I'm gonna do it again. And as you can see, it's just configuring a wireless router and clients. So we're gonna go through putting this together. I'm gonna shrink that down, and I'm gonna bring over the one that I like to always put inside of a Word doc so you can see it clearly. You see this packet tracer here. A lot of work, but let's get to the point. The point is we're gonna connect devices, we're gonna configure a wireless router, and then we're gonna configure IP addressing and testing connectivity. As you can see right here, it's just simply in a scenario a friend wants you to help set up their network at home, and you decided to do it. Remember this, people, the more knowledge you get in this field, the more people who are gonna ask you to come help them put their stuff together. So let's go ahead and start outlining and putting it together. Remember, this is a simple little thing. It shouldn't be hard at all. So let's just get right through it. So first thing we want to do is go to the cable modem and the splitter and do some connections. So I'm going to go here to get my wires. Yes, my cable wires and my copper straight through cables. And the first thing I'm going to do is get that coaxial cable because we got a splitter here, and I'm gonna click on that and get coaxial 1. Then I'm gonna come over here and get port 0. Simple little setup. You know this, you got this, you can handle this. Then I'm gonna come over here and get another coaxial cable, go back to my splitter, get that too, and this time I'm gonna run that over to the TV right here. I don't know why that's happening, but we on the TV. Right there, 0. Okay, so we got that set up, and now we're gonna double click on it and turn the TV on. We're gonna get a little picture here. There we go. TV is working fine. So we was able to do that. Simple. Here's the outside of our house internet, your ISP going through the cloud, and we here at the splitter, and we set up the cable modem. Simple stuff. Now what we want to do is we want to select a straight through cable, and we want to connect the cable port 1 to the router internet port. So we're going to go to get a straight through cable here, and we're going to go to cable modem. We're going to go to the cable modem right here, and we're going to do port 1, and we're going to go right across to the home wireless router. Okay, router port, and we're going to go to the internet for this one. Okay, so we took cable 1 and we went to the internet and we knocked that out. If you see any weird lines coming up here, I don't know if something's going on with my network, but I see a little weird lines. If you see it, cool. If you don't worry about it. It shouldn't damage anything. With that being said, let's go to the Office PC and click to the wireless cable modem. So I'm going to go get me another straight through, and I'm going to go to the Office PC right here and get that. And then I'm going to run that to the router, right over to the router. Click it and get one. And then I'm going to do the same thing for the bedroom. I'm going to come over here, click up here, get that, and run that straight to the cable modem. Click that and get two. So now we have all our connections set up. Looking good, looking good. Not another one. So the next thing we want to do is we want to configure some wireless router settings. Okay, so I'm going to go into the Office PC, desktop PC here. And then I'm going to go over here and then I'm going to click on that. Now we are at static, but I want to be at DHCP. I want to make sure it automatically get IP addresses so it can work on its own. And you see that the default gateway is 192.168.0.1. We want to remember that, okay? Because we're going to click here, browser, web browser, and we're going to type that in, number in 192.168.0.1. And if we did that successfully, we should go to a username and password setup menu. You should be changing this at home if you haven't changed it. So with that being said, we're going to come here to the maximum number of users and we're going to turn that to 10. And we're going to go ahead and save that. And the reason we're doing that is because we don't need 50 people logging on to our system. So we're going to change that to 10 and make sure that people can't just log into our system. Okay, it timed me out. It said, okay, you've been in here for a while. We're going to time you out. I'm going to go ahead and close that. And then I'm going to go right back into it because I want to get back in there and make a few more changes. 192.168.0.1. Yes, you'll do this a lot when you're messing with routers, even real world routers in the real world. Real world routers in the real world. How funny was that? Okay, we are acting like we in the real world. Don't explain it. It wasn't funny. Okay, so now we got the maximum number changed. You see that that is 10 right there. And we saved it. So let's go ahead and mess around with some of the, what we call administrative settings. So I'm going to come here and I'm going to go to the administrative tab right here. And as you can see, it's a lot of tabs up under here. But I'm on management. I'm in the management plane. And I'm simply going to change the password. And I'm going to check to see if the password has been changed. So let's go ahead and do some of that. I'm going to go down here and save it. And then I'm going to put in the admin name. Just remember, you should be changing your password. Just see if it changed the way we wanted it to. Let's see if we got in. It says successful. So woohoo, we did it. We did it. So the password has changed. Now I'm going to go ahead and put in another password. So remember, I have to remember these passwords because people are going to be asking me for this information to get into my system. But we're going to go over here to another tab. We're going to go to the wireless tab. And remember, we got little wireless connections up under here. And for the wireless tab, we're going to go to 2.4 gigahertz. And we're going to change the SSID. So we're going to change that. Instead of to default, we're going to rename that SSID My Home. I'm just going to call it My Home. That way, when people come into your establishment or go ahead and ask you, hey, I want to connect to your network, then you can go say, no. It says here, when it says here, SSA broadcast, we're going to broadcast it. We're going to leave it enabled so people can see it. And then we're just going to save. We don't have to do anything but save it. And there we go. So that's been saved. And that don't say you successfully saved it. I don't know why I don't say it, but hey, we're good. Okay, so then we're gonna make another configuration change in here. We're gonna go this time to wireless security, which is right here. Remember, you gotta look under here and see these tabs. Some of them you can see clearly. And we're gonna come to 2.4 and we're gonna change that to WPA2. Okay. Now we're going to put a passphrase in here, and I'm going to put the same passphrase I had before because I don't feel like changing things. I'm just going to put that as my passphrase. Hey, what the heck? What can it say? You didn't put it in. You didn't put it in. Okay, now we're going to come over here, and since we got that in, I think I just clicked on Save Settings. Since we got that in, we're going to close that. And then we're going to go close this browser. And then we're going to go over to the laptop. So now what I want to do is go over to the laptop. So I'm going to close this too. And I want to go to the desktop PC wireless and connect tab. So I want to go to this here where it says laptop. And I'm going to go to desktop. And I want to go to PC right here. And I'm going to go ahead and click connect to see if we can get it connected. I'm going to refresh this and see what happens. As you can see, when I click refresh, a lot of information kicked off here. And I'm going to click here and I'm going to go ahead and click connect. Now it wants a passphrase. So let me see if my passphrase work. I'm going to go ahead and click connect. And it looks like we are working. It looks like we are up. We are connected. I'm going to click it again. Put the passphrase in again. And go ahead and click connect. So we up and running, people. Now, I believe we up and running. Once you click connect, you can put the passphrase in. We were good. So we did that. I want to go ahead and click on a profile. Now, this is not in the description, but I like clicking on the profile. You have successfully connected to the access point. So it's saying I'm successful here. I'm clicking on the profile just to look in there. And it looks like everything is connected. Okay, so let's go ahead and go here. I'm going to close that. And I'm going to go to the browser. It says now we're going to go click on the browser right here. Double click it. I'm in the browser. And I'm going to drop in this simple web address and see if we can get some action in this. Okay, and you can see that it successfully logged us in. Welcome, Skills for All. So that's pretty much it on this particular PC. We can go check the other PCs and all that. But we see that we were successfully able to wire up everything. We were successfully able to change the configuration of things. And we were successfully able to set up our wireless PC. So when people come in, they can get access to our particular devices. We did a great job here, people. Like I always say, make sure you watch everything all the way through. And you can see that we successfully accomplished this. This is Professor Cisco. I'll see you in the next video.